the end of the showreel that we have this year. I'm going to be showing you a lot of videos in this presentation. So first of all, a bit of history, just to put you on what we're going to be doing today. We're going to give you the background of Next Limit. As I said, a quick 101 on how to use RealFlow, not in depth, of course, but and then some tips and tricks. So just going back to the old ages when I was born, I was doing my final year, like some people here are doing at Bournemouth, in Mallorca, and they had a very good animation school there. And I was doing my project, and I tried to do water characters, and that was 1998, and they told me, no, you cannot do them. So I was gutted because I come from an island, I grew up surrounded by water, going to the sea, and then suddenly I couldn't do water in CG, so, you know. But what I didn't know is that at the same time in Madrid, two guys were building RealFlow and creating Next Limit. So it's a kind of funny coincidence that it was the same year that I was trying to do water and they were building RealFlow. And what they had that year running, fun enough, is this here. So this is the first ever simulation done in RealFlow. And according to what they say, this was like 1,000 particles. Remember, this is 1997, 1998, on a Pentium 4, and it took an overnight to sim this, just 1,000 particles. So you look at that now, it's like, that's a joke. Come on, it's 16 years ago, so that was a big achievement, and they have gone a long way since then. So I moved away, I came to London, I was working in Soho with some of the guys that are actually doing talks here at Bournemouth. And when RealFlow 3 came out, that was 2004, according to this timeline. I was working at MPC, and I managed to do like X-Men 3 shots that I should have somewhere here. Reference videos. Yeah, and I cut this from my reel, so I hope it doesn't have dodgy sound. Can take that out. So that was what I did in X-Men 3 back in the days. With RealFlow 3, it didn't have Python scripting, it didn't have anything. It was a pretty good package. Some old shots, just from an old guy like me. So RealFlow was evolving, and we got to 2008. And that was a big break for Next Limit because they got awarded a Technical Achievement Award for their input in the films by creating the first commercial product that did fluids. If you see the timeline, the top part is RealFlow, versions, and achievement. The bottom bit is what else does Next Limit do? And as I mentioned earlier, we have Maxwell render that is coming after this presentation. And we also have XF, which is Xflow, CFD package for engineers. So we are a busy company. When they started, there were 2 guys. Now we are approximately 60 people working in Madrid, in Spain. And we have people scattered all over Europe and the US as well. So this is pretty much Next Limit history. I joined in 2008. I didn't have anything to do with the Oscar. But after that, I've been just teaching how to create fake water, as a friend of one of my colleagues says. So what's the philosophy of Next Limit products? Essentially is keep it simple. We know that there are a lot of products in the market that do effects, some products that can do fluids or liquids, like RealFlow can, but everyone does it in a different way, and every single product has its strengths and weaknesses. Our strength is that we have a small learning curve. You can learn RealFlow in no time. It's pretty straightforward to pick up, and I can show you in no time how to use it. So first of all, and before I move to this slide, I should have shown you, 2014, we released RealFlow 2014, and now we're releasing like a single version every year, which is like pretty cool as well, because we listen to customers, we implement new features that you can use every year because you need them, not because they have been put in the software. And this is the technical reel that we put together for this version. So this is a kind of the enhancement that you may find in the version that you currently have here at Bournemouth. So first of all, and for those of you that used RealFlow in the past, now we have shelves. So you are more into the 3D packages. Every single package has shelves, pretty much. We didn't have them until this last version, but they are not there just because we wanted to add shelves. They're there for a reason, and that is because we now have like a massive and a very powerful system called RealFlow graphs in RealFlow 2013 that allow you to do things like eyes in soft image, Houdini bobs, or thinking particles. So with shelves that we have created and RealFlow graphs, you can drag and drop stuff directly from your Python scripts or your graphs into the shelf. So you can customize your pipeline. You can do a lot of new things thanks to this shelf, which are not exactly the same shelves that you can find in other packages. And this is just an example of one of our guys creating his own tools and putting them there. We have added a shortcuts editor, so you now can edit your shortcuts, something that wasn't possible in previous versions of RealFlow. For example, F, you can put it as focus if you're a Maya user. We have added a new viscosity solver for Hybrido. Some people think that RealFlow didn't have viscosity, and that's kind of a wrong assessment since we always had viscosity in the smaller scale solver. We didn't have it in the first iterations of the large scale solver, which now is a flip solver. So in 2014, we have added this pretty cool viscosity solver that allows you to do tons of different liquid interactions that can be even used for small scale, even if it's a solver that's created to do large scale simulations. And it also allows to do like variable viscosity, which is pretty cool. That example that you kind of split or define different areas to have different values for viscosity. And this is, example is in one of the demo scenes that we have now in the software. This is something that we also introduced in the previous version in 2013, which was demo scenes. So you can now learn the software, not only by reading the manual, going to the forums, but also by opening the scenes that we provide with the software. This is another cool feature that we added. This is one of the diamonds that is how we call forces and helpers. And it's called the ocean force field. This one is the bubbles. And we have new flip secondary elements. And this is the bubbles emitter. Single click, you just generate bubbles that are going to rise to the surface, create foam. We have managed to speed the simulations quite a lot. In this case, it's like 25% faster. And I have this file, actually, of a file for this simulation that I didn't show, but I will show you right after this video. So you can compare what we could do before and now what we can do. These are the simulation graphs that I was talking about. Now they have an interface, so you can reorder the evaluators. That is how we close the chains. And then you can also create an interface for the parameters that you want to expose to the users. So you can have a massive or complex graph, but you only expose what you want the user to touch or to interact with, which makes it way simpler for people to get a hold of this. This is the ocean force field I was mentioning. I just got mixed up. And this is very cool because it kind of places a force on top of a simulation, so you don't have to do anything, and you can like quickly see what the effect is going to be before simulating. And it can be used not only with the fluid, but also with dynamics. RealFlow, some people don't know that they have a very cool dynamics package. In this case, the ocean force field is used with the texture to drive the force. Again, a painted texture that I created in Maya. Another cool feature in this version is we added tendrils to the sheeted demon, which is one of the forces that kind of close the holes that you sometimes see in the simulations, and especially when you're doing the slow-mo effects and you want to do like liquid for fluid, for food or something. You want these like nice, gooey looking tendrils, and that is pretty easy to do now in RealFlow 2014. We have added a visualization gizmo for the forces, so things like this one, which is like the displaying demon that I will see later, are much easier to master now. And the meshing, which has been always very, very good inside RealFlow, now is even better because it's interactive. You can define an area, you can click on the interactive button and simply concentrate on that area to fine-tune it before you decide to create the whole mesh. So now, if you moved around the bounded box, it's going to be updating with the filters that you touch. So it doesn't have to recalculate the mesh at every single step. And we have added also extensions. And this is pretty interesting because You don't need to simulate, in fact, you cannot probably simulate a massive area when you only have an interaction in some specific part. So you can concentrate in that part, just give enough space for the simulation not to overlap with the extension, and then the meshing will take care of the extension and will blend the whole ocean patch. And on top of that, you will add the displacement at render time, and you're done. And this goes into the 3D platforms with the same parameters. So when you do that at render time, you are using exactly the same names for the parameters than you have inside RealFlow. So before I move, I'm going to show you that scene that I mentioned, the one with the submarine. And I loaded this particle cache. So you saw earlier that I play a clip with 1,000 particles. Checking here, you have 116, almost 16 million particles in the viewport generated for that submarine that is coming out of the ocean. And it moves in the viewport. I'm moving this interactively. So that's how cool it is to do fluids these days in RealFlow. You can move a lot in there. And if you look into the memory consumption, I think it will go like, well, we have a lot of things open here, but it's not that big. I think it's about 7 gigabytes that it uses. If we go to the process for RealFlow, it will probably show up. Well, it's using 11 now. Well, not that bad either. So how easy it is to use RealFlow? We go now. We could start by seeing what a couple of guys that we had in the office not long ago did with the software. They came with pretty much no knowledge or limited knowledge of RealFlow, and they did things like that. First, I'm going to show what one of them, which is a different type of, I mean, he's not an artist, he's a researcher, and he was looking for a way of using RealFlow to create a different way of parameterization in the solver. So he says, okay, I want to move one step at a time, a single parameter, and find a way of, instead of using the values or a slider, to use different type of representation of how this changed. And he created this, like, I think it's 64 variations of viscosity. We don't need to see all of them, but I can quickly open, and this isn't installed properly. Just go to, yeah. So this is like value 1 for viscosity in the large scale solver. And if we just skip a few of them, we will see the different behaviors of the fluid. This is 16. If we scroll, 29. It's the same simulation. He just added something pretty straightforward, simple, drop it down into like his teeth. The funny thing is that he went to the dentist when he was in Madrid, so he built these teeth. I was like, is that a dentist? Is it a tooth? Yeah, it's a tooth. Okay, whatever. But the behavior of the fluid is spectacular as it progresses, like increasing the value for viscosity. It's pretty stable. And it's rendered from inside RealFlow using Maxwell render, which is also pretty cool. And he's now doing his thesis or his final research in Germany. So you should see this one coming soon into our website with some more details and some other scene that he's been working on. But the results are pretty cool. You know, it's like toothpaste. And now when that is in the website, you will be able to go there and say, okay, if I use this value, then I will have this result. So you don't have to do like the R&D yourselves, which is also pretty cool. And one of the last ones, the fluid almost breaks. And it's always the same simulation. It's just increasing the value one step at a time. Cool. So the other one is an artist. He wanted to be an FX or generalist, like many of you that are here at Bournemouth. So he started doing things with liquids. I'm going to show you just these two clips. This one first because it shows that we also have dynamics. I mean, we gave him some basic training in the office on, okay, these are the dynamics inside RealFlow. We have a cool solver, it's called Caronte, and it's pretty accurate, stable. It doesn't show jittering or explosions. So he did this. At first I was shocked because of the sound that he used, but then it goes better. Let's put it in full screen. So you see that he's using the dynamics, and he was exploring pretty much everything that he can do inside the software with no knowledge. I mean, he had been toying around, as he says, with RealFlow, but his name is Quentin Rosero, and he's actually looking for jobs. So, and since I'm mentioning internships, we do have internships at Next Limit. Just talk to us after the presentation, and we'll give you the details. So if you want to come and learn RealFlow, Maxwell render, just let us know. So this is showing the interaction between the fluid and the dynamic, because everything inside RealFlow is coupled, so you can do both things, and they interact with each other. You can use the fluid to use a force that breaks things, for example. And the final example that he has here is something that he did with Python scripting to kind of vaporize some fluid. That's one thing, and he's working currently in his final project, which is also going to be pretty interesting, like a massive scene with the hybrid solver, and this is just a few frames of them. He would be adding like volumetric cloud with OpenBDB rendered in Maxwell. So, as I said, pretty straightforward to use RealFlow, and here is why. Everything in RealFlow is kind of color-coded. You have to think, when you get to see the interface, you have to think, okay, blue is for particles, so my liquids are going to be all these nodes in blue, because some people are really scared about using nodal graphs. We introduced this nodal system to connect everything together in the 2013 version, I believe. And we're trying to make everything simpler and simpler in every iteration of the software. So blue is for liquids, red is for diamonds, that is how the forces and helpers that allow you to control the simulations are called inside RealFlow. And yellow is for geometries that you want to drive also, or to collide with the fluids. And the green is normally the result that you want after you do a simulation. When you have your particles simulated in RealFlow, what you want to do is to create the polygonal surface around those particles and get that into a 3D platform or into a render, because you can simply move the particles into the renderer and measure render time. So if we go to RealFlow and quickly create a new scene, okay. So the first thing, I press the G key and I get the grid. So we have a reference. Inside RealFlow, the default units are meters. This is 1 meter, this is 1 square meter. So you have to bear that in mind when you are moving things back and forth from your 3D platform. In here, like I said, it's like a normal 3D package. You can customize the interface you want, moving the panels around just by simply holding the mouse and reorganizing things. You can save different layouts if you are happier working in a different way. We provide 2 different ones, like one that is more related to customizing tools using scripting, and the other one is the normal 3D, let's call it that. You can go to preferences and decide where to export your scenes, etc. You can change the axis setup that you have depending on the platform that you're going to be interacting with, RealFlow and Cinema, or Lightwave, or Max, Maya, Houdini, XSI. If you're using Modo or Blender or other packages, as long as you have files that RealFlow understands, such as, for example, FBX, Alembic, OBJs, you can move things back and forth. And we have also an SDK for the render kit, so if you want to build your own tools that work with RealFlow on your 3D application, you can do it yourself if you want. So in 3 steps, you can create something now in RealFlow. Let's say that we want just simply add a liquid emitter. Instantly, you get to see this thing here. If I press simulate now, it's going to ask me to save. Say, call it SPH, like small solver, and it goes to command line. Actually, this machine is going to be simulating today in command line because the graphics card has a problem with the driver and we couldn't update it. But I can quickly say, don't go to command line, play in the viewport. It's going to be playing slightly slower, or way slower than it should, but that is due to the graphics card. So right now, click simulate, you get something going, but nothing interesting because there are no forces, no colliding geometry. So if we simply come here to the dimension, and they are not forces because you have forces, which are pretty much all these ones. Some are not exactly forces. And you have these ones with a K, which are called killed diamonds. So they kill things because they want, no. Because if you want to kill things that are outside the volume, you can use this one, because if you want to kill particles based on age, you use this one, etc. We can check that one later if there is time. So we created some liquid. We want to add, for example, some gravity, and they are getting hooked together here in the relationship editor, we call, into a hub. This is the default behavior. And how do we know that these two are linked? There is a button here that says show implicit links. So if we click it, we see that there is a link between the two of them. If we can click it, then we know that they are there. It's fine. If we don't want to use the hub, we can always get rid of it and simply drag one to the other, and you have the same effect. They're going to be connected. So if I want to have some geometry, I can have a plane and hide the grid. And if I simply link this again, or I can forget about the hub and simply link this tree now. So the fluid is linked to the gravity and the plane. I hit simulate, the fluid is going to collide with the plane and splash out. Okay, nothing spectacular, but this is like 1, 2, 3 clicks, and you have something going. Now we have the three colors: red, blue, yellow, and the one that we're missing is the green for the mesh. Simply we can do the mesh tab, and we have particle mesh. This is like normally for the smaller scale simulations, medium scale, tabletop fluids. And we have this hybrid mesh, which is for the large scale solver. So we click on the particle mesh, and cool thing from this last version, we added the interactive meshing. So we can click here, it meshes it. If we're happy. If we want to tweak it, we can come to the bounded option, simply concentrate in an area that we want to mesh, and it interactively meshes it. So it's cool. So unbound it. And since we're here, we can say, okay, I don't want to see the particles now. I want just to see this mesh. 7890, change the display mode, the same as here. I can come to any object inside RealFlow, go to the Maxwell render tab. This is why I mentioned that we had Maxwell embedded. And you can hook up any material from the Maxwell material library, or you can use either the default color. So if I have this rendered as red, and I come to the display tab, there is a fire button. Fire is a fast interactive render engine, Maxwell guys call it. I can press F6, which is the hotkey, and I get that render. And it's interactive. So if I change the color, it should change the color. But better than having just plain colors, we can come here and use the preset that we have. So we have honey preset, we have blood preset. So this is how simple it is to set up something that looks cool in RealFlow with Maxwell. And if you want, instead of using a global illumination sky, physical sky, just use an IBL, get the Maxwell HDR material that we provide, or use your own ones, apply, and you get a different illumination. Okay? So this is like the 101 for doing liquids inside RealFlow. What about dynamics? Dynamics is pretty much the same thing. So instead of having meshes, you don't need it, because the geometry is actual geometry that you can move around the 3D packages, but you need the forces or diamonds to drive the simulation. So again, just simply create something that can bounce over something, for example. So we come to the Dynamics tab, and we say this is an active rigid body. And if we check here in the Nodes tab, now it's an active rigid body. This one, by default, they are set to no. We want it to be passive rigid body. And if we add the force, like gravity again, and we can hide the gizmo, it's too big, or we can leave it aside. The three of them are connected. We can see that. We can see that they are linked together. If I simply hit simulate, or better than that, probably reduce the settings, so the quality, I want it to draft. I just want like a basic of the basic, because this doesn't have any complexity. I don't mind if it vibrates or not. Normally it shouldn't vibrate. So if I hit simulate, it stays there. If I want this bouncing, I come to the rigid body, and I say elasticity is set to 1, same for the cube, so they share, and that should bounce. What if I wanted this to be more complex? I can come to the demo scenes, and I can look any of the demo scenes that we have here for the Caronte solver, which is the name that we have for this solver. So now that we are kind of away from the simplicity or the ease of use of RealFlow, what's next? How does RealFlow fit into your pipeline? As I said, we have connectivity plugins, and all these are free. You can go to the website, and the same place that you download the RealFlow packages, you download the connectivity plugins, you download the RealFlow render kit. And we have it for the Autodesk Suite, Max Maya, Sofimage. We also have it for Side Effects Houdini, Lightwave, Cinema 4D. And this is how it works. You're going to be always, or most of the time, moving geometry from your 3D platform into RealFlow to do your simulations on top. And then you're going to be getting back particle, meshes, and probably volumes, which are not here. If you have volumes, then you're going to be using the render kit, because the fields that RealFlow exports, especially for the secondary elements in the hybrid solver, they're exported as OpenBDB, and they can be rendered with the render kit. We have native formats like RPC, bin file, and SD. These are like the RealFlow optimized internal ones, and we also have open source formats such as OpenBDB, Alembic, and of course OBJ, FBX, Maxwell render. We also export to Arnold format these days, and we are compatible and export to Krakatoa. If we go to Maya, and I have loaded the plugins, if you go into the plugin manager, and this is the same for all the platforms that we support, because the icons that we provide to the plugin developers, and we give a specification, so they name the things accordingly. So if you move from one platform to the other, and you know how to use it in that platform, you know how to use it in the other. It's exactly the same workflow. In here, I just loaded the RealFlow plugin, and I loaded also the render kit plugin. Let's say that I want to come here to the visor, and this is one of the things I like to do most, is like take advantage of things that Maya or Houdini have, so we can reuse them in our examples. Could come here to the motion capture examples, and I say, okay, I import this character, and this might be my animation. Okay, I believe it's huge. So come here to outliner, or select the geometry, scale it down, that one. What I'm going to be exporting is just a geometry, right? So I want that to be way smaller, because this is huge. I know there's 001 in this case. So I have that character down there. And this is doing like a run or something like that. Yeah, quite weird. So it goes over for 37 frames. So I say 37. And I come here and say, export that into SD format. I don't think you can see the SD here. I want to export using the whole playback range. I want to export the selected object. And I use deformation because this character has deformation. So I want to put that into, let's say, I call this SD. Oh, yeah. So I export it. And when I come into RealFlow now, create a new project. I can say, come into the geometry tab or come into import, hit import. And if we go to Illustrator, desktop, 101, we have the file there. So get the camera, and we have the same camera, same guy, and we have this line here telling us that it only has 37 frames. So what can we do with this character now? We can do anything inside RealFlow. We can even emit particles from it, use it as a solid object to drive distraction, whatever. Let's check the notes. OK, so that's how you get things inside RealFlow. What about getting things from RealFlow into Maya or other packages? It's the other way around. You get this particle meshes, and you load them back. So I think I have some particles from the previous tests in here I can use. So let's say, and they are in RPC format. So if I click on this one, create, I'm loading frame 95 from some simulation that I had somewhere. And it should be loading probably a lot of particles. So there you go. It's quite a lot of particles that I had simulated from RealFlow, and this is the way that you import them in Maya. The downside of importing using the connectivity plugin is that it creates, in this case, a Maya particle emitter and particle system, which means that you cannot fit that many. You know that Maya and normally the 3D platform cannot fit that many particles in memory. So to avoid this and to avoid the bottleneck that sometimes you create in the networks when you are passing data around, not only particles, but imagine that you have a huge simulation in RealFlow, you want to mesh it out, and you want to move it into your 3D platform. You are taking this space and you're taking network bandwidth. So to avoid that, we created the render kit. And if I want to load this exact simulation using the render kit, I simply come here, call the same file, not the one. And it will create just a point representation in the viewport of the particles. But the thing is, I can use still all the attributes that they came from. Oh, this is a different file. Cool. Oh, doesn't really matter. It's much controllable, and I have a lot of things to do with it. Like in here, I can load multiple sequences in the same emitter. I can play with the radius. I can clamp the velocities for motion blur. I can modify the size of the particles based on the attributes. Any of the attributes that I exported from RealFlow can be used to drive the simulations and in terms of shading. Depending on the renderer, and I have here mental ray, renderman, Arnold attributes, I can use different type of primitives to render these particles as. So there's a lot of controllability that you can have with this. I don't think mental ray will handle this, so we can give it a go just to see how it looks. But especially mental ray is the one that has a huge problem with particles in Maya. So Maxwell flies with particles, so we never use mental ray. It's taking a while. I'm gonna be moving on, I think. But before that, I can probably do exactly the same test, but with instead of rendering the particles, which we know kills Maya with mental ray. Kill. Come on, man. Come back to me. Let's kill Maya. Good that we're killing Maya and not RealFlow. All right. Let's go back for 1 sec so I can show you how cool the render kit is to mesh at render time. Maya 2015, somewhere here. Okay. Anyone has any questions so far? Meanwhile, this load. Come on, shoot. No? Okay. All right, let's go back to render kit and starts. Okay. It hasn't been loaded. It's because it crashed or I killed it. It didn't say the preferences that I had loaded both of the plugins. Maya is quite slow when you move these things around. Okay, render kit loaded, RealFlow loaded, close. Okay, so if because I know that simulation I just loaded comes from Hybrido, I can create a Hybrido measure object here, and I can load those particles, and the particles will get meshed at render time. So if I load them from, I think that was the last place that we look at. Yeah. So if I go to frame 68, bring them back. Yeah, it's like a dense mesh, and if I simply select mental right now and render, it should render in not much time. We can keep going meanwhile that does it. So this is pretty much the pipeline between your 3D platforms and RealFlow. And now, before I go into a bit more detail on how to do things in the different solvers, I wanted to give you a couple of tips, if you allow me to call them tips. partly this came from one of the presentations that I recently saw in one of the many events that we attend from Ryan Summers from Imaginary Forces. He was giving like a 50-50 from the trenches tips that you can check in Cineversity website, I think it's called, for Cinema 4D. It's very good because it's like especially for people that are not that used to a software. How do you get into something that is new and don't get lost? So he kind of inspired me to do this kind of extra tips while I'm doing presentations. This is a basic one because when I was studying, like you are now, one of the first things that they told me was, if you do an animation, you have to learn how people move. Go to the park, sit on a bench, look at people, how they move, so you can understand the basis of nature. And this here is a book from a good friend of mine that we used to work together in video games, and he has a very good point, that's why I put it here. We sometimes forget that we're doing art. In whatever that we're doing, effects, animation, modeling, texturing, is a sort of evolved art from the old masters' art. So we should go back and look not only to nature, but also to the many sources that we have to understand how things should be. And if we look at the good ones, we will end up doing good things. So I totally recommend that. This goes to this thing here, which is something from my hometown. I'm from the Canary Islands. I don't know if you've been there. And this is a local painter. I used to love going to this museum. I still go every so often when I go to visit my family there. And the interesting thing about these pictures is that this guy in the early 20th century used to hire a guy on a boat to go into the sea and look at the colors of the corals and the fishes before he started painting. So he was actually researching before he got into the painting program that he had at the time, which was a canvas and some paint. So just to bear in mind that we should prepare and plan things before we do them. We cannot jump into a program and get frustrated. We have to know what we want to do before we jump into it. Same with any type of museum. This Turner shipwreck is awesome. I mean, you can see there that you could check and try to do that in CE. How you do it? Well, you have to research, you have to do a lot of work. But now we have things like Pinterest. And this is one of the boards, the many boards that I created when I'm doing like my own stuff and doing references. So I encourage you to go and Google it. Everything is online. You can do videos, you can find anything there. In the past, these guys didn't have, and many people that were starting doing other types of art didn't have. But now everything is accessible. So you can, if you want to do bears in a river, you can find bears and you can start like collecting references all the time. So get your reference. If you need the car that is splashing out, before you go into the 3D platform, before you go to render, how does that look? Well, it depends. It depends on the simulation, and if you have a client and the client will come with just one idea and then you don't know what to tell the client that this is going to look like, well, do your research and there. Ooh, I shouldn't show that. Okay, that was like the off track from the RealFlow side. So now we're going to try, and I think that we're doing okay for time. How are we doing for time? Anyone knows? I don't want to be late. You want me to cut out? No. I'll run quickly on to the next steps. Okay, since I mentioned more or less this is like a crazy meme that they put there, like, where do I find my forces? If you come from a different package, you don't know what the forces are, especially in the old days. Now they are like clearly in a shelf. But you don't know that none of these on the top are, well, not all of them are forces, as I was saying earlier, so I already explained that. RealFlow, you probably have seen what I was showing in the different videos, have two different types of liquid solvers. One is like small, medium scale, which is the SPH one that's been there for the last 16 years. And then we have the new one, which has been there for the last 3-4 versions, and we keep updating that one because it's the one that it will evolve faster. That doesn't mean that we are not taking care of the small scale stuff, because as you saw in the reels, small scale is like 90% of our user base still, and it will be. And probably a lot of people will grow in the business just doing like small things. So we need to take care of that. And we are creating new solvers for these customers. And what these customers are doing normally are splashes, blot, melting effects, and you can do other cool stuff like creating web maps. So quickly show you how you can do this stuff. Maybe we can even use this guy here. So since we have it, why not use it? So imagine that we want to shoot at him some particles. We can simply link the two of them together, as we show. And I can put a high speed velocity in the character. And in the small scale solver, the thing that you have to look for is, and just with like 3 tips on how to get your simulations going. If you want more particles, you go to resolution here. There are 2 types that you will normally use. One is the dumb particles, like ballistic particles, the same ones that you get in Maya if they are not M particles. And liquid particles. These are the ones, the liquid ones, that have like liquid properties, as the name implies. And you have here also something that many people don't know, and I should have shown another thing here, which is the F1. If you press F1 in any parameter, you get contextual help. And this is why I was mentioning about the tips earlier. Apart from the documentation, you have this. This is part of the documentation. If you want more info on a parameter, you simply click here and you get the full docs. So the documentation, and we have a guy dedicated the whole year, and it's very frustrating for him that people don't know that there are so many places where you can access his work all the time. And this is the best way to learn the software when you don't know how to use it. So yeah, okay. So you have the resolution, you have the viscosity parameter you can tweak, and this is how you get more particles in the speed. So you increase that, you get more particles. And they kind of kicking me out, so I'm going to run out. If you want to get wet maps, which is like the sliding textures, so you get that feeling, simply come into the object, and in the liquid particle interaction that gets created every time that you link something, you say, sorry, not in that one, in the texture one, you say wet dry texture, yes. So it will become black, and when the particles start shooting, and now we have an issue here, right, that one. I just locked the timeline so it doesn't move, and the particles go there. But this is like colliding, yes. You start to see like there are like white dots in there. I will have to refine this, and this is because it has UVs. So if the geometry has UVs, it will create a texture, and you can find that texture afterwards and in your project and use it in shading. So instead of going to the next slide, what I'm going to do is like quickly show you a couple of the scenes that we have in the demo scenes. Like if you want to do a like large-scale simulation, you have tons of them here. You have that U-boat is there for you to play with it. And it loads. Yes. So you have the U-boat that comes out of the sea, and you have the scene description to explain what it's doing. You can read the notes that we put in the scene description to understand what's going on and what to look for. Same goes for pretty much anything that we have inside RealFlow. One very handy tool that we have, and not many people use these days because it's old, but it's very, very useful, is the real wave stuff. You can create a single surface, and if you want an object to interact with it, simply move the object across, just to create like some wakes. Pressing the K key, it creates a keyframe. Move it here, create another keyframe. You see all these went orange. And when I reset and simulate, since they linked, and I'm not going to export anything. Whatever. It's going to command line. Okay, let's take the command line off. It creates a wake. If we put it in shading mode, we see the wake. So it's that simple. You can create particles on top of the wakes. You can do other stuff. You can add, because these wakes work in like in a layer version. You can add the statistical spectrum, hit reset, you get like that wave. You can customize that. This is the ocean statistical spectrum, similar to the Houdini hot, etc. I'm going to finish with just a couple of tips. Go to the website. There is a lot of resources in there. You can find our colleagues Luis Miguel blog. Unfortunately, we don't have internet here, so we cannot show you the links for these things. I was trying to tell you one, viscous fluid dynamics. We've seen some. This is the, again, there are tons of examples that you can check to understand this new visual scripting that we have put in place. And maybe I can finish with an old reel. So it's getting so slow now. I'm out, Mihai, I'm out. Don't pressure me. You see, these people. Just go one step back. It's going really slow now, I don't know why. It was still rendering that mental ray image. You see, Maya mental ray. Should have used another renderer. Oh, we never got to see that. All right, kill. That's why. So just finishing with one last video so you see on the dynamic side of things. Videos. We have this cool presentation from one of our clients, Crytek, that they use RealFlow dynamics inside their latest game, the Rise, Son of Rome. And they use it because they didn't have any other solution that could handle this type of simulations in the way they wanted. It's like very thin, coupled pieces, like thin bamboo shots they mentioned to us when we were trying to do some R&D for them. And they are glued together with what we call multi-joints. And it is because we had Alembic as well as OpenBDB in the pipeline for them that they could use this and import it into the game. This is actually their engine for testing. And the guy said that he could train 3 artists in half an hour and start using the RealFlow dynamics straight away. So this is how easy it is also to pick it up. One last, if Mihai allows me. Just one. Because I brought some of the old reels from RealFlow, not 2014, but the previous ones, and some have some really cool stuff I could quickly show so you see how RealFlow has been used in the last years to create amazing stuff in films and commercials. And we have here, like, this is RealWave being used for Narnia. And these are like the RealWave I just showed you with the boat. And then we have the Girl of the Dragon Tattoo intro credits. That was all done in RealFlow. This is another intro for a game. This is a high reader shot with extension that I didn't got to show you. And these are probably some of the biggest shots ever done with RealFlow. Again, Mr. X in Toronto. They were using like 60 machines in their farm to generate all the foam and splashes for these simulations done with the large-scale solver. And this is a Houdini RealFlow mixed pipeline. So again, this is RealWave from the mill. And I'm wrapping up. So my colleague from Maxwell can come into stage and tell you all about the amazing world of Maxwell. All right, thank you very much. If you have any questions, I'm somewhere there. Sorry, Mihai.
You talk too much.
I talk too much. I can talk for hours. You know that.
Okay. We just set something up.
Take this afterwards.
I just need a couple of minutes to copy a file, and I'll be okay. Where do I put the laptop? Oh. Okay. No, I'm gonna just copy the file because I downloaded it. So. Yeah. I'm not gonna transfer anything. I'm not gonna disconnect anything. It's okay. okay. Hello, can you hear me okay? Yeah. So my name is Mihai and I've been a Maxwell render user since its alpha days in 2004. So I'm not sure if you knew how old it is actually, but it's still new in many ways. So since we only have 45 minutes, I'm going to try to do very small parts just to get your interest, and maybe you can download the demo and try it for yourself. So first I'm going to talk about the main parts in Maxwell which are important. So lighting, emitters, materials, and then I'm going to just quickly go through some scenes so you can see how quickly and easy it is to set up motion blur and depth of field and lighting and all that without artifacts or things like that. So just to start off, I'm going to mention a little bit, what the rendering world still is, what the rendering world thinks the real world looks like when you got all this stuff, right? Because you're not into lighting, you're into rendering, right? So you have to know all this stuff, right? Okay, and it's a never-ending list of stuff instead of this, which is really what you should be concentrating on. Because if you're here, if you're at the school, if you're students, what you're interested in learning is not a render engine. What you're interested in learning is lighting, because you want to transmit a message to people via images, right? So when people see your images, when people see this, nobody's going to give a crap about all this stuff on the left, okay? No matter how good you are with that, nobody gives a crap about that. They give a crap about lighting, okay? So Maxwell is all about light, okay? It was the first render engine that removed all that stuff and tried to optimize as much as possible, but still keep things real. And I'm going to show you that in Maxwell. If you know photography, if you know how a camera works with f-stop, with shutter speed, and what that does to the depth of field and so on, you get that immediately. You don't have any area light samples or stuff like that, depth of field samples and all this stuff. So I'm going to try to show you very quickly that, what you should be concentrating on, and hopefully what Maxwell can help you develop is your sense of lighting. So what you should be studying if you're into rendering or lighting, it's people like this that you should be studying, okay? You should be studying render parameters, okay? This is what you should be studying. This is what you should be achieving, okay? So really, take a look at all these people. I mean, probably you can tell some of these who they are. And study lighting. Don't study rendering, okay? Well, before I go into that, I'm just going to quickly show you how you can set up a scene in Maxwell Studio. In Softimage, the application that is still alive. And I'm going to show you the plugin in Softimage. If it's open somewhere, yeah, there. So I'm just going to open a pretty simple scene, just to give you an idea how lighting works in Maxwell, and that it works just like a real photo studio, So here I just have this geometry with a backdrop, and if you want to add lighting in Maxwell, you need to add it as a material, and you need to add it to a real piece of geometry, okay? And that piece of geometry can usually be just a single-sided polygon, okay? Because it's going to act like a sort of softbox for you, and like in the real world, okay? So I've added that, and then I'm just going to add a material to that. So the emitters in Maxwell are just components of the main material system. So to add an emitter, to create an emitter from this, I just click on the Maxwell layer and say Add Emitter. So I don't have time to go all over the plugin specifics in XSI, but it works pretty much the same in Maya, in 3D Max, in Cinema 4D. So we have 14 plugins, which you get for free with every license. So we don't have a scheme where we make you pay for each plugin. You get one license and you can use any application you want. And we have, I think, 15 plugins now. Anyway, so here's my emitter, and here are the emitter settings, right? So the most important thing is this, the luminance type, or the power, how you want to specify how bright this emitter is. And you can either use lumens, right? So that's a pretty common, if you're a photographer, you know what this means. It's sort of like how much light does this emitter put out. Or you can just use power and efficacy, which means if you have a 40-watt light bulb and you know its efficacy number, which the manufacturer usually gives you, then you have a pretty well-calibrated scene, because we sort of calibrated the Maxwell camera with these different type of lighting. So, you know, if you have a scene where you know in the real world you have a 40-watt light bulb, just leave it like this and it's going to illuminate the scene correctly. But I usually just like to use lumens. It's a little bit easier, so put there 3000 lumens. And then I'm going to start Maxwell Fire, which is Maxwell Render's interactive render engine. So this is like a tweaked version of the same render engine. So it's not a different render engine. You can actually use all the regular Maxwell materials in Maxwell Fire. It supports everything: motion blur, volumetrics, subsurface scattering, everything. It's just that we tweaked it a little bit so that it calculates the easy light paths first. That's why we call it an interactive engine. So I'm going to show you it's good for some things, and it's not so good for other things. But mainly for determining the lighting in your scene, it's perfect. So you can see that pretty easily you can get very nice lighting. And I didn't have to tweak any samples or so on. I'm just going to make the emitter stronger. Okay, and it makes the scene stronger, lighter. Or I can go to my camera settings, and here I have the Maxwell attributes, and you can see that it works just like a regular camera, right? You get the f-stop, which determines how much light comes into the sensor, and also your depth of field. So, for example, if I do a very large f-stop, I'm going to get a very shallow depth of field, right? So you can see you get a depth of field for free, so to speak. I can move this around to better focus the camera. Right? So I can change the film ISO. That's also going to affect how much light my virtual sensor sees and so on. So anyway, about the lighting, I just want to show you that it just works like in the real world. So, for example, now you can see that I have soft shadows. Okay, I didn't have to set any area lights. I didn't have to tweak any caches or things like that. I'm not going to get any artifacts here if I'm going to animate this scene. And you can see how fast it is really to get a good idea of how the lighting is going to look in your scene. So, in the real world, if you wanted to have sharper shadows here, what would you do? You would just make this emitter smaller, right? Then you have sharp shadows. Okay? And then you get maybe more interesting contrast and so on. So really that's only everything you have to do as far as emitters are concerned. And also you can cheat a little bit. So for example, if I like this angle, but the emitter's in the way, you also have a little bit of leeway, because you can, for example, you could add a mesh attribute and hide that emitter to camera, which you wouldn't be able to do in the real world, right? All right, so you can see that even though this is not a particularly fast machine, it's not a dual core, it's not a dual CPU machine, very fast, within seconds, you can get a very accurate view of what your scene is going to look like. And also, you can use Maxwell Fire to render out quick previews of your animations if you want to do that. You can use it as the main render engine if you want, right? It's just a matter of changing it in the render options. One thing I wanted to mention how Maxwell works in rendering. So I'm going to show you the render parameters it has, really. And it's one thing that new users get really stuck on, and they sort of abandon Maxwell because they think it's too slow. So for example, if I render this, actually I'm going to change the render options. Okay, so these two here are basically your render options. The rest are just options that don't have to do with the quality of rendering in any way. So you have the render time, and you have something called a sampling level. So Maxwell is not a bucket renderer. It just renders the whole image in one go. It's just that as the sampling level is low, you're going to get a noisy image. And as the sampling level increases, the noise clears, right? So Maxwell is going to stop rendering when it reaches either the render time first or the sampling level first. And one thing you have to be careful about is not to set the sampling level very high. So for example, here it goes to a maximum of 25, and that is insanely high. You know, you almost never need that much sampling level, because if I set this time really high, let's say 14,000 minutes, and I render this very simple scene. Actually, wait a minute, it's too small. I'm gonna increase the, let's make it 1,000 pixels. Okay, so I start rendering this, and here I get something very strange. Okay, Maxwell is telling me time left 10 hours, okay? So people see this and say, you know, are you kidding me? This is going to take 10 hours to render? I can't use Maxwell for production. But no, that's wrong, because you use a too high time value and too high sampling level, because this render is not going to need SL25. You're never going to have a render that's going to need SL25, okay? Most renders, especially if it's open spaces like this, they need maybe SL14, 15, okay? And then you can run just maybe a little denoise. You can see that in 40 seconds, it's basically almost clean. You can just let it run for maybe 30 seconds more to clean the shadow areas here a little bit, right? So the actual render time is not going to be 10 hours. It's going to be more like 1.5 minutes for this, right? With virtually no setup time and very accurate lighting, very nice lighting. So that's important to keep in mind if you're going to download the demo and give Maxwell a try. Just remember that it's going to stop when when either of these are reached, right? So in cases you want to do quick previews of your scene, you could just let it for 5 minutes, and let's say I set this to the final sampling level. Then it's not going to reach sampling level 16 in 5 minutes, so it's going to stop after 5 minutes. Then when you want to do your final render, you just set the time basically very high, and then leave it at the final sampling level that you want. But another pretty cool thing with Maxwell is that you can resume a render, okay? So if I render this, actually I'm just going to render it for 2 minutes. Or, well, 1 minute. Okay, so you've done your test sequence, you've done your test animation where you let each frame render for 1 minute, and you can see that even after about 10 seconds, you already get a good idea of what the lighting is going to look like. And you say, okay, this lighting is good, let's go on, let's move on to, you know, render it some more. You don't have to start from the beginning. You can actually just click render again, and then Maxwell knows that it has an MXI file, which is Maxwell's image format, in the same output folder. So if it sees that, it's going to ask you, well, do you want to resume the render and just move on from sampling level 6, or do you want to start from 0 again? So you just click resume, and it's going to resume rendering from that sampling level. And you can do that at any time. You can even close Maxwell. You know, you can close your computer, it doesn't matter. As long as you have the Maxwell scene file, the MXS, and you have the Maxwell image format file, which is the MXI, and you haven't changed anything in them, then you can always resume the render at any time you want, which is a pretty nice feature. Next, let me show you. Yeah, I can show you multi-light, which is one of Maxwell's great features. I'm just going to copy this emitter over. I'm just going to maybe put it on the other side. Rotate it around. One thing to keep in mind with emitters is that they're going to emit the light in the direction of the normals. So if you click to see the normals, just make sure that if you don't see any lighting in your scene, just make sure that the normals are pointing in the direction that you want. And if they're not, just flip the surface. All right. So now I'm going to create, I'm going to duplicate also the emitter material. So you can see that in Softimage you also get the preview of the materials, a Maxwell preview of the materials you have. So I'm going to duplicate it and apply it to that one. So I have two emitters. And I'll just let these render. Oops. And in the render options, all you have to do is turn on this option, multi-light. Okay, so by default it's disabled. You can either use intensity or color and intensity light. So if I render that, just put the camera back, look at an angle, sort of like that. So what is multi-light? Multi-light is very cool because it allows you to change the influence of your emitters while Maxwell is rendering, right? So you can get very different looks from the same render. Okay, so for each of the emitters in your scene, you're going to get one of these sliders. And you can also solo one emitter. So if you have many sliders, instead of turning all of them off, you just solo one. Sort of like an audio mixer analogy. So you can see how useful this is. Either you can have something like this, which is maybe one type of mood, right? Or you can just switch it around and create something like that from the same render. So you can do this, again, because Maxwell saves out this MXI format, which is an HDR format, which is proprietary to Maxwell. You can always open up this MXI file after you render, you know, a month after if you want, and still have these sliders so you can play with these in Maxwell Render. And actually, you also have access to that multi-light functionality in Nuke, After Effects, and Photoshop via our free plugins. Right? So hopefully that gives you a taste about multi-light. And if you set it to color plus intensity, then you also have a color chip here where you can change the color as well. So I mean, now you could probably do this maybe in other renderers, but Maxwell was the first to present this idea, and it's still the most smooth to work with, I think. Right? Maybe we can. So anyway, hopefully that gives you an introduction to lighting and rendering, or lighting in Maxwell, and you can see that there are no tricks, there are no settings for controlling like in other renders. You just have intensity, so how strong the emitter is. You can change the color, of course. You can also use an HDR image to project on the emitter, so you can use that as an emitter. It's going to emit the colors, the different colors from the HDR image if you want. You can also use a IES profile, so we have support for that as well. So yeah, that's about emitters. How much time do I have? No, not that one. Yeah. That's from the beginning. Wait a minute. Right, so just to recap, if I wrote these tips if you want to try the demo, because most people make these mistakes in the beginning and they give up very soon because they don't realize about the sampling level and how to set it, right? And I'm also going to show you, if I have time, how you can, basically with multi-light, because you can separate out the different emitters, you'll notice that some emitters in your scene are going to have virtually no noise contribution in your renders. Others are going to be very noisy. But since they can be separated with multi-light, you can just run a denoiser much heavier on one of your emitters while not touching the other emitters in your scene. So I'm going to show you a quick example of that if I have time. Another thing which is very important is to check your scene scale, okay? So Maxwell works in meters in the metric system. I don't know if you know what that is, the metric system. It's like, you know, it's not what you use here. Anyway, don't use, you know, astronomical watt values like 100,000 of watts. I've seen people do that. If you notice that your scene is too dark, either check your scene scale because maybe it's too big, or change your camera settings as you would in the real world, right? You change your ISO, your f-stop, your shutter speed. And also try to imagine how light is going to bounce around in your scene, because if you have an open space scene where the lighting comes from every direction, that makes for easier calculations for the renderer. The most difficult scenes to render in any renderer are going to be interior scenes, especially if you have like a room where the door is slightly opened and the only light is coming from the other side. So if you want to illuminate that room with any renderer, it's a very difficult situation. So it's the same in Maxwell. Open space lighting is going to be much, much faster than interiors. And yeah, if you use displacement, keep an eye on the displacement settings and your RAM. If you use pre-tessellated displacement, we have two methods in Maxwell. We have also one called on the fly, which is great because it doesn't use, you don't have to worry about the RAM, but be careful with on the fly displacement if you have very big height displacement, okay? Because that's going to be slow. So if your render fits in RAM with displacement, use pre-tessellated because it's going to be much, much faster than on the fly displacement. So we have those two methods. And of course, read the manual because we spent quite a lot of time to make it as thorough as we can. Right, so those are the sort of a recap for the emitters in Maxwell and how they work. Okay, and new in version 3, this is pretty cool that you can have an emitter, you can say, okay, I want this emitter to only affect this surface and not anything else in the scene, so you have much more flexibility with how you light your scene now in version 3. Multi-light, I mentioned that. One thing to keep in mind though, okay, so the more separate multi-light sliders you have, the more RAM you're going to need. And keep in mind also that color multi-light, if you do need it, it needs 3 times the amount of RAM as intensity only. So if you notice that Maxwell crashes at the beginning of the render, it's usually because you're running out of RAM. So that's the first thing you should check if you don't have too many multi-light sliders and you have a huge resolution. But anyway, by today's standards, if you have 24 gigs or 32 gigs, you're probably not going to run into that problem. And also, multi-light doesn't actually increase the render time. People seem to think that, but it doesn't. And going back to Fire, just real quick. So it's very good for checking your lighting, your depth of field. Like you saw, you also get the depth of field visually in Fire. If you want to check displacement, of course, it supports the displacement as well. So all the materials in Maxwell, you don't have to create separate materials just to use Fire. It's the same material system. And you can use it as the main render. What it isn't so good for, it's if you have perfectly specular materials. So if you have something like a perfect mirror, it's not going to show the reflections very fast in those. And it's also not so good for previewing SSS, so subsurface scattering materials or caustics, really. So for those, you're better off if you just do a quick test render in the production render for those. So moving on with materials. Actually, before doing that, let me just show you one other scene, just to talk about the lighting and scene setups. Well, actually, no, I'm gonna hide that from you. And Okay, so this is just one of the very, quick test scenes I did to show you motion blur and how quickly it is to set up the scene. So I'm guessing you know what's going to happen to these bunnies. So everybody tortures them, the Stanford bunnies, so they're going to blow up. And yeah. So what I wanted to show you here is that, you get a very, so this motion blur here is not just, it's deformation motion blur, it's very heavy. You have many hundreds of different pieces flying around, and you get no problem with artifacts, flickering, things like that. And I'm going to show you how quickly it is to set up these materials, for example. I mean, they look pretty good, and it's virtually a matter of seconds to create those. I'm going to show you how. Yeah, so also if you want to turn on motion blur in Maxwell, I'm going to show you how you can do that and how quickly it is to set that up. So this was the scene in Softimage, so it's going to run a little bit slow because this is actually an Alembic file, which is about 2.5 gigs.
10 minutes left.
10 minutes?
Yes.
Yeah, I'm going to... No, it's 20 minutes left.
No, 10 minutes.
Yeah, but that's because you went overtime.
But they have 10 minutes, sorry.
Okay, I'll try to speed it up.
To show the showreel and the full thing. So.
Yeah, okay. Well, anyway, so these are the bunnies flying around. Right? And to set up motion blur for this, all you have to do are two things. Right? You go into the camera settings, go into attribute settings, and here you have something called rotary shutter. Now, if you don't know what that is, look it up on the net. It's the way a film camera works because it doesn't have a curtain shutter. It has like a disc that spins around to control the motion blur on the final film. So if you want to match that up with footage shot at 24 frames per second, just turn this on and set it to a shutter angle of 180 degrees. And that's going to match up the motion blur between the footage and the render very well. Okay, so that's the first thing you have to turn on. And the second thing, go to render options and turn on motion blur, right? And then the motion blur steps, that's how many steps it's going to think before and after to create the motion blur. So in this case, we want motion plus deformation because it's not complete objects we want motion blur on. It's all these little pieces. And that's it. Those two things are the only thing you have to do to create that motion blur you saw in the clip, right? Let's see, we're running out of time here, fortunately. Just quickly go through this. So the material system, this is real volumetric subsurface scattering, so it's not any fake subsurface scattering. Caustics, of course, very easy to get in Maxwell. You get those automatically. You just place in the mirror, you create a glass material, you get these very accurate caustics. We have a lot of clients who do jewelry because we have materials to create diamonds and gold very easily. So in version 3, we added these so-called material assistants. And I do encourage you to use them because they're called assistants, but it doesn't mean that you're going to create a material that's not good quality. It uses behind the scenes the same material system, advanced material system. So I'm just going to quickly show you that very quickly because we don't have any more time. Oh, that's the that's Studio 2.7. Okay, right. Let's get the new one. So this is Maxwell Studio. This is a sort of like a partner application to Maxwell Render where you could, it's very useful for debugging your Maxwell scene files. So usually that's what I use it for. So you can load MXS files and test here and create materials, set up cameras. You can also import objects, so you can also create a Maxwell scene from scratch in case your main application that we don't have a plugin for it. But anyway, this is the material editor up here. And to create a material, you just go New, So right-click here, new, metal, for example, right? And you have this. These are the material assistants. So here you can choose a preset, for example. Like you want a brushed aluminum, you get a, it only takes a few clicks. And you can change the preview scene here. Let me see, gold. Okay, so if you click here, convert to advanced, you get a glimpse of what the advanced material system looks like. And that's what the assistants do behind the scenes. They change all these parameters for you. So for example, we have a transparent assistant, and just a click and you get a very nice looking glass material with caustics already and everything. You can use a preset. This is too dark, so we increase the transparency. So the controls are pretty self-explanatory. Car paint, shader, or assistant, hair, right? This is useful for hair. So we have hair since 2.7. Anyways, so we don't have any more time. I'm just going to show you, if you're interested in trying the new version, we added lots and lots of things to version 3, which I don't have time to go over. So just go to maxwellrender.com/v3, and you'll get a preview of all this stuff. Like for example, scattering. You can scatter geometry very easily. So since it's an extension to Maxwell, you can actually do this in something like SolidWorks or Rhino or SketchUp, which don't have these kinds of tools, but they're extensions to the plugin, so you can use those directly into SketchUp via the Maxwell plugin. So this terrain was created with the new Maxwell C, which was also added in version 3, and it has a little bit of volumetric scattering, which we also added in version 3, and all these little leaves on these little palm trees have subsurface scattering actually on them, right? So it's no problem for Maxwell to render massive, massive scenes. The new procedurals in version 3, which can also work for displacement, of course. And also the new 360 degrees lens. So it's very easy. For example, you can create environments in Maxwell, render them with the new 360 lens, and then reuse that as an HDR image in your renders. Right. So I think that's it. Oh, I'm just going to finish with the Maxwell Real for 2014, since I don't have time to show you more. Right. that's it. Hope you download the demo and enjoy Maxwell. Thank you. Do we have time for questions? Or no? Yeah?
How do you get a hold of Maxwell for like students?
We do have a student learning edition, which I think is $90, something like that, and it's a full version. You can do whatever you want and render up to full HD, I think. No?
Actually, if you're a student at work, we don't have free licenses when customers are free laptops.
Ah, there you go. It's free. Can't get better than free. All right. Any other questions? No? Okay. Well, actually, I didn't even show you. Well, we're running out of time, so. So this is using also the new Maxwell C, which is sort of like shot in a virtual swimming pool. So I just put a plane of C up above there, and you can see it's actually creating volumetric caustics because we also have a volumetric object here, new in V3. So you don't see the edges of the swimming pool, so to speak, but you can see the caustics going through the water on the cloth. And that's very easy to set up as well. You just take a look at the manual, and it's going to explain it to you all these things. All right? Okay, that's it.